Now that we've looked at GCF factoring and factoring by grouping, we're going to move into factoring our trinomials. A nice little typo right there. Just trinomials where a equals 1. So to review, if we think back to multiplying, okay, I'm multiplying two binomials and you either FOIL or you box it and you end up with a trinomial. So now instead of going from x plus 3 times x plus 4 to x squared plus 7x plus 12, we're going to work backwards from standard form and get it back into our factors, our parentheses. So whenever we have a trinomial and my a value is a 1, we have a pattern. If you notice in that example we just looked at, there's a relationship between positive 3, positive 4, and positive 7, positive 12. If I take these two numbers and add them, I get a positive 7. If I multiply them, I get 12. And if you think about that, whenever we FOIL and I multiply out x plus 3 times x plus 4, my first terms are going to give me x squared, right? That's where the x squared comes from here. And then my last terms, 3 times 4, are going to give me the positive 12. So if I find numbers that multiply to 12, and then my outer and inner are going to give me my like terms that I combine to get my 7x. So I got to find numbers that multiply to 12 and add to 7, or in a general form, we want to multiply to C, add to B. Sometimes it's going to be very easy. Sometimes you're going to have to make a list because it doesn't come into your head as quickly. All right, so in this case, my B is 9 and my C is 20. So I want to find numbers that are going to multiply to 20 but add to 9. So if I make a chart, I like to go in order. All right, so I'm going to start with 1 and 20. Well, 1 plus 20 is 21, not 9. Then we have 2 and 10. Well, 2 plus 10 is 12, not 9. 3 does not go into 20. Then I have 4 and 5. 4 plus 5 is 9, so those are going to be my factors. And then all we have to do is write out our parentheses. I want to put the x first, and then I have a positive 4, positive 5. Now that we've looked at GCF factoring and factoring by grouping, we're going to move into factoring trinomials. The first type of trinomial we're going to look at is where a equals 1. So, quick review. Whenever we multiplied x plus 3 times x plus 4, if we did it by FOILing, x times x, our first terms, gives us x squared. X times 4 gives us 4x. 3 times x is 3x, and 3 times 4 is 12. My like terms are in the middle, so I have x squared plus 7x plus 12. Okay, so that's multiplying it out. Factoring is the opposite. I want to know what multiplies to get my product. So instead of going from two binomials to a trinomial, I'm going to work backwards and go from a trinomial in standard form to two binomials in factored form. Okay, now if you notice, there is a relationship between this 3 and 4 and the 7 and 12 in my answer, in my multiplied standard form. Okay, we're going to use that every time we factor. So again, this only works when a is 1. So in front of my x squared, it's got a coefficient of 1. And I want to look for numbers that multiply to my c value and add to b. And those are the numbers that are going to go into my parentheses. If we go back, 3 plus 4 gives me my b term of 7, and 3 times 4 gives me my c term of 12. So in this case, my b is 9, my c is 20. So I want to multiply to 20 and add to 9, so we can make a nice table. Now, I find it easiest to go in order whenever finding the factors, especially of bigger numbers. That way you don't skip any. So if I'm thinking about 20, I know that 1 times 20 equals 20. And then if I add those, I get 21, not 9. So those aren't the ones that I want. If I go to 2, we've got 2 times 10. 2 plus 10 is 12, not 9. 3 does not go into 20. 4 goes into 20, so I've got 4 times 5, and then 4 plus 5 is 9. So those are my winners. Those are the factors that I want to use. My next step, once I have my factors, is just to write out my parentheses. Now, the reason this works is because if I put an x first in both of my parentheses, X times x gets me to x squared. So this coefficient of a 1 isn't going to change the relationship between these numbers. So I'm going to put my x's first, and then I have a positive 4, positive 5. So factored form is x plus 4 times x plus 5. Again, you can always check by foiling or box. So we'll box this one. So I need a 2 by 2. And I have x and positive 4, x and positive 5. X times x is x squared. 5 times x is 5x. X times 4 is 4x. 5 times 4 is 20. Find my like terms, and we end up with x squared plus 9x plus 20. So we multiply to C, add to B. For the next example, same thing, I'm still going to multiply to my C, which in this case is 12, and add to B, but now my B is a negative 8. So in order to add to a negative 8, I either have to have two negative numbers, or I have to have a small positive number, and then my negative number be bigger, right? Well, in order to multiply to a positive, I need to have two positives or two negatives. So in order to multiply to a positive but add to a negative, it automatically means I have to have two negative numbers. Right? That's the only way that I'm going to get two numbers to multiply to a positive but add to a negative. So that's just something to keep in mind. So I want to multiply to positive 12 and add to negative 8. Starting in order, I'm going to say negative 1, negative 12. That gets me to negative 13, not negative 8. I've got negative 2 and negative 6. That gets me to negative 8. Stop. Don't have to go any farther. That's my answer. I'm going to go to my parentheses, put my x's in the front, and then I have a negative 2 and a negative 6. And that's factored form. For our third example, we've got x squared plus 2x minus 15. So now I'm multiplying to a negative 15, but adding to 2. So in order to multiply to a negative, I've got to have one positive, one negative. And I'm going to keep in mind that I want to add to a positive. So that means that my positive has to be the bigger number. So I'm going to multiply to negative 15, add to 2. I'm going to start in order. So I've got a 1 and a negative 15, as well as a negative 1 and positive 15. That's going to give me a negative 14. And this one's going to give me a positive 14. Either one of those are 2. 2 doesn't go into 15. 3 goes into 15. So I've got 3 and negative 5, or negative 3, positive 5. 3 plus negative 5 is negative 2. Negative 3 plus 5 is positive 2. So those are the numbers that I want to use. So go to my parentheses, plug in my x, and I have a negative 3 and positive 5. So now let's remember from the last time we had a video where we talked about solving in the zero product property. So if I have two factors that have to multiply to get 0, that means at least one of them has to be 0. So in order to solve for what x could be to make it a true statement, I'm going to set both of these equal to 0. So to solve for x, I need to subtract 1, so then x equals negative 1. On this side, add 8. So then x equals positive 8. So I have two options, negative 1 and positive 8. So to solve by factoring, I'm going to factor like we just did, multiply to C, add to B. And then I'm going to say both of those factors and set them equal to 0. Right? Anytime we solve, it's going to be an equation, not just an expression. So I'm going to have this equal sign in here. Before you factor, it's got to be set equal to 0. Alright, so this one's ready to go. My C is negative 27, so I want to multiply to negative 27. And my B is 6, so I want to add to 6. So now I'm multiplying to a negative, adding to a positive, so I'm going to have one positive, one negative. So if I start in order, got negative 1, positive 27, or 1 and negative 27. So that's going to give me a 26 and a negative 26. Neither one of those works. 2 doesn't go into 27, so we got 3. So I've got negative 3 and positive 9, or 3 and negative 9. Negative 3, positive 9 gives me 6, and that's the one that I want. So I'm going to say parentheses with x in the front and a -3, +9. Now remember, this equals 0. That's my equation. All I'm doing is rewriting this trinomial as the equivalent factored form. So now to solve, I'm going to say x minus 3 equals 0 and x plus 9 equals 0. Solve for x, I'm going to add 3. So I get x equals 3, and then solve for x, subtract 9. So then x equals -9. So those are my two solutions to this quadratic. If you notice, this is a +3, but I started with a -3 in my parentheses. Remember, anytime we're working with parentheses, the value is going to be the opposite sign.